in the middle on both ropes, and then, not a great drawing, but, and then I had a rope kind of tied in the middle, but kind of loose knot right here, so that it could slide like right here. So it could slide this way, but if you pulled it, then it would kind of drag this middle bit and pull that one part.
And is it kind of loose on both, on the top and the bottom?
Yeah, both knots. Both of these on the middle part are loose, but not like loose enough to fall apart.
Okay, so I'm just going to kind of reproduce that on my personal little whiteboard because I want to compare different people's ideas. Ziad, do you have a different one?
Yeah, kind of the same idea. Let me just draw it out.
Okay.
So I thought I remembered only one of the knots actually sticking out when you pulled on it, and the rest of them were kind of basically they got tucked in. So I was thinking that there's like a knot here that's connected to one one of the pieces of rope here. And at the same time, it's also kind of connected to the other two pieces of the rope. So when you pulled on it this way and kind of pulled everything, it would basically pull everything in. So I was
Okay.
thinking more like
So
this.
it's kind of like a three-way thing.
Yeah. So basically, if you pull on this, all three of these would move inside, and then something like that.
Okay. All right. I think I see what you're saying. All right. Who else has a different model? Catherine.
Yeah, so I drew it. Hopefully it'll let me do it this time. Come on. There we go. Okay. So I drew it, drew the cylinder, and then I figured there was a rope going from the top two holes and then a rope going from the bottom two holes, but then they were like twisted in the middle, if that makes sense, because I don't think it'll let me erase.
Okay, what do you mean by twisted in the middle? That figure eight thing that you drew. Can you explain that to me a little better?
Uh, trying to think. Do I have strings in here? No, I don't. Okay, but I've got ponytails. So almost like, your two strings and then have them in like crossed and then twisted and then going out separate holes so that no matter which one you pulled from, all the other strings would be affected somehow.
Okay. Okay. Yeah, I think I saw with your illustration. So,
Sorry.
no, that's okay. So you're saying they kind of come in, but then they kind of have a tangle almost
Mm-hmm.
in there, something like that.
Yeah. Not even a knot, just almost like they're twisted together a little
Like they're
bit.
twisted together a little bit. Okay. Yeah, again, I don't think I can, I don't think I can erase that, but
Yeah.
I'm going to draw something like that on my own little one that I'll try to represent that so we can talk about them all and maybe make modifications if we need to. Who else? I know there were a lot of people with their hands up and some of them may be in the same groups, but who else from a different group had a different model?
Mine was pretty similar to like everything being connected in the middle, but I said like, a PVC like cross that can go four ways.
Mm-hmm.
I said it was like that in the middle. So basically the same as the illustration in the top right, but like they were connected with a PVC, cross thing.
Like they're passing through a PVC like four-way connector.
Yeah, either that or they're four separate ropes and just like in or something like that.
Okay, so you're saying we have, when they come in, they're just making like a T, essentially. They're just
Yeah.
kind of connected somehow there?
Yeah.
Like, okay, so in a way, it's kind of like a four-way strand of rope.
Mm-hmm.
Okay, great, awesome. Let's see. And you're Caitlin. Okay, did anyone else have a different idea? I know someone had another idea. I sense it. Anyone? Okay, so if not, that's fine. What I'm going to do is I'm going to put them up on showing it, sort of my little sketches of them on my whiteboard, and then we're going to do a little poll. So can you guys see that? Yes. So let me. Give me a second to set the poll up. Okay, so I'm setting up a poll, and I want everyone to vote on which model they like the best. And you may like more than one, but pick the one that you like the best. All right, still have one person that needs to vote, who's probably in the bathroom or something. Okay, so let me show you the responses. So looks like people liked Ziad's the most, and then Wyatt's, and then Catherine's, and then Caitlin's. Maybe, now first of all, maybe they're all right. I mean, or let me say, not all right, but maybe they all work. They can't all be right, but maybe they all work. Let's kind of go through them one by one, from starting with Caitlin's, where Caitlin just has them basically connected in the center. So if maybe we put these knots like this, so one of the knots is sticking out. And if I now grab, let's say, the bottom right and pull it, will it work? Will it bring the knot in? Just raise your hand if you can see, if you believe with this model, if we pull the bottom right in, that the top left is, sorry, pull the bottom right out, that the top left will go in. Raise your hand if you feel like that works. Okay, so about around half, maybe. If you don't think it works, why do you think it works? Someone tell me that. Ziad?
So I was just thinking that if you pull from the bottom, the bottom right part of the rope, it wouldn't move because of the knots on the bottom left side and then the top right side.
So you're saying these guys, it's like too tight?
Yeah.
So that it wouldn't be able to move? Okay.
Yeah.
All right. That's an interesting point. That's an interesting point. Let's look next at Catherine's. So she had them twisted together. Seems a little similar to Caitlin's, but maybe a little different. Catherine, can you articulate what makes your model different from Caitlin's?
I'm not sure I understand exactly how Caitlin's works.
I think hers, maybe it's almost like 4 ropes coming in and meeting at a spot, and they're kind of fused together at that spot.
Okay. Caitlin, I hope that's right. I'm sorry, I don't understand.
If it's not right, Caitlin, let us know.
Well, if they're fused, I guess that just makes that fused point almost like the point of origin for any force that's going to act on those ropes. So just imagining pulling down and to the right, I can picture that happening.
So I guess what I'm
where
asking is about your model, how your model differs.
Yeah, I know. I guess mine's probably not going to be as effective because it's just a twist in the middle versus more of a fused point. There's not going to be as much strength there, so it may not work as well.
Okay.
I'm sorry if that makes no sense.
No, that's okay. I guess unfortunately, I'm not super clear on the twist, you know,
Yeah.
even though you showed me a minute ago with the magic with the hair ties. But so that makes it really hard for me to assess this one. Let's move on to Wyatt's, which was sort of the second place answer. And raise your hand if you think Wyatt's works. Okay, so I saw 4 hands. Let's maybe 5. Let's go ahead and draw some knots because you kind of have to. I didn't draw the knots before. He did, but you kind of have to have the knots there. So first of all, if I maybe I'm gonna use. So if I pull with the blue is my pull. So if I pull the left top, the right top definitely seems like it will go in. Hold on, I want to read that comment. Catherine's like a U up and a U down twisted in the middle. So maybe like this. Something like that. Okay, we'll come back to that because now it's a little more clear. But talking about Wyatt's, if we pull on the left, raise your hand if you think the top right is going to go in. Okay, I think a lot of you see that. What if I pull on the bottom left? If I pull on the bottom left, we kind of have 3 things we have to check. If I pull the bottom left, why is it not drawing? Okay. Will the top right go in? Raise your hand if you think pulling the bottom left will make the top right go in.
On mine, I had
Yeah.
knots on the inside, kind of near, like on both sides of the loop,
Mm-hmm.
so that it would kind of catch when you're pulling it from, like if you're trying to get the corners to go. That's like there were like 2 knots on the inside.
Like here and here?
Yeah. Yeah, on both.
Okay. So what you're saying then is when we pull this, then the whole like this thing has to kind of tilt. It
Yeah.
gets sort of moved over, and when it tilts, this has to kind of move a little bit to the left.
Yeah.
And that's going to pull this in a little bit.
Yeah.
Okay, I can kind of see that. I'm wondering if maybe there's it would pull it in enough, because it really has to pull in about 6 inches of rope, and this can only move side to side about 2 inches. So,
Yeah.
but I see what you're thinking. So, okay, so this is what I would say. I would say maybe this model looks like it's maybe a check minus. Like, it kind of works, but maybe not 100%. It has some of the right features, but there's a little bit of, uncertainty. What's going on there is there's not enough distance here. If this would move all the way from the right to the left, it can't bring this whole rope in.
Yeah, I think maybe I was thinking like if you have like the piece of rope and you have the 2 knots, and then it's like you have the loop in the middle, and then the knot is like in the middle between the loop and the side of the inside side of the tube, so that there's a little more room, but not too much more.
I'm sorry, I didn't follow that. You can, maybe I'll put the whiteboard up again in a minute and let you try to draw that, what you're
Okay.
saying. But I want to come back to Catherine's, because now that I see this, let's test it again. So if we put our knots like that, and then we pull the bottom left, and this bottom string, it kind of loops over the top string. When we pull it, I'm kind of seeing maybe this does work now for this test. Who thinks you can visualize Catherine's working on this test? Because if we pull it in, what's going to happen is this top rope has to kind of come down like that, and then the knot has to kind of move in, because the bottom one becomes flat. So I think it does work for the diagonal test. Does it work on the side-to-side test? Let's check that out. If we just pull, going back, maybe get rid of that green thing that I had, and we instead pull here, will this on the right come in if I pull on the left? Raise your hand if you think so. Okay, a lot of people say that. The only other thing we would want to test then is, what about if I pull the bottom right, will the top right go in? So if I pull the bottom right, then this thing has to become straight. And when it becomes straight, the one on the top has to do this. And I believe that would have to move the knot in. So we can vote again on it, but I think that worked. Whereas maybe Wyatt's, as I've drawn it, and again, maybe my drawing's not right, maybe almost works. Let's get to Ziad, because it was the most popular. Ziad, why don't you talk us through yours a little bit again?
So again, just looking at your demonstration, I thought that I remembered that 3 of the knots would get tucked in once you pulled on one. And I thought that they all should be interconnected, especially when you were pulling diagonally.
Mm-hmm.
So I thought that 3 of the pieces of rope should be connected to one. Yeah, I don't really know how else to explain it. But like with my design, you should.
Is yours sort of the same as Caitlin's, but with longer ropes, or?
I don't know.
So is this a knot? This is right here as a knot. So
Yeah.
basically we have 4 strings connected with a knot.
Right.
And so let's just see then, if we pull this and we have sort of slack, which is maybe what Caitlin intended and I didn't draw it properly. If you pull this in to the right, this knot is gonna move down, and that would, I think, pull this in. Okay, all right. I can sort of see that. Raise your hand if you can see that. Okay, now how about if I pull on the top right? Then what's going to happen is this will move over, but it may only move over about 2 inches, unless this is loose. So I guess the question with it, if it's kind of loose, maybe as this pulls out, this eventually will get moved in. But I think there's a question about how much slack there is and if there's enough rope in there to for it to work. I'm going to give this one in my just based on my current understanding of your model, and again, because of the, we're communicating this way, it may not be perfect. I think it again kind of works, but maybe it's a little problematic if these are too tight. It looks like how I had depicted Caitlin's, and maybe there's not room enough to pull. And if it's too loose, then as you pull, this one doesn't have to really start moving. Let's observe the actual device again. Okay, so here's the device. When I start pulling, the rope kind of instantly starts moving, right? And let's see if I pull diagonally. And there's a lot of rope. This can go quite a ways inside. So there's a lot of extra slack there. So what it says to me is that a model like Caitlin's or Ziad's, maybe we would have to, in order to know if that model could be right, we would have to actually take measurements and sort of maybe even build our own little mock-up of this and see, like, does it fit? Does it fit within the space? So I think I'll give these guys check minuses, but Catherine's model seems to work perfectly. There's no kind of doubt, like how much rope is inside. Now, is Catherine's model right? Well, we don't know. We don't know if it's right. And that's what I'm trying to illustrate here. We can have, actually, I've seen probably 15 different models from different students in different classes. 15 models that work 100%, that are not right, that are not the correct model, because I know what's the correct model because I built this thing. So when we're doing physics, what we're doing is we're looking at some phenomena, and we're making models trying to understand how it works. And then we communicate those models with other people, and they have their own models. They want to find a problem with our model because they want their model to be right. And it's often the case, not just sometimes, it's often the case that there are multiple models that all explain everything you see. And so when you get in that situation, we don't know how to say one is right or one is wrong, because just like there's no way possible for you to get a hold of this thing and open it up and look inside, right? You cannot get to it. You cannot look inside. That's how the force of gravity is for us, or the force between electrons and protons. We cannot open it up and see what's inside. All we can do is try to think of new tests we could make to differentiate between these models. So, for example, there are some things we didn't do. Like, I didn't try putting all of the ropes kind of part way in, and maybe when it's like this, pulling one and seeing what happens. Looks like they all go in. And I think Catherine's model still works with that test. Here's another test that I didn't do. Now, does that test tell us anything about Catherine's model? Do you,
Something on the inside of it.
yeah, there's something inside. It does not sound like a rope. It sounds harder, right? It sounds like there's something hard inside. And so once we do that test, we go, oh, well, maybe Catherine's model's not right because it doesn't have some hard object. Now, if I pull them all out, I can't hear that rattling quite as much. But when they're a little bit loose, there's actually something hard rattling inside. I can probably hear it better than you can hear it through the microphone. And so as a physicist, I look at these models. The best model to me, and that's my opinion, but the one that seems to work the best is Catherine's, and yet I found a new experiment, a new phenomenon that says there's maybe a problem with hers. So could we fix her model? That's what we want to do. We don't want to just scrap it entirely because it works really well to explain a lot of the stuff we see. So typically when we have a model that works for a while and then we find a new experiment or some problem, then we try to see, can we fix it? Can we make a minor adjustment and save that model, and then we have an even better model? And the bottom line is, what's happening, this is an illustration and a metaphor for what physics is. In physics, we observe these phenomena in the world, and we try to make models to explain it, and we can never prove that the model we have is right. All we can say, the best we can say, is it explains everything we see. And there's always room for a new test, a new experiment to show up and you know, and invalidate. So the things I'm teaching you in this class, in fact, every single thing we learn in this class we already know is wrong. Okay? They're all a bunch of models that work really well most of the time, but there are certain cases where they are wrong, and we have better models that are more advanced. If you were interested, you could take more advanced classes and learn about some of those models, but those models almost certainly are incorrect as well. So what I'm teaching you in this class is not the truth about the universe. We don't know the truth, and we have no way of ever knowing the truth. What we have are models, and the hope is that as our model explains more and more things, maybe it's closer to the truth, but at least it's a useful model. And that's what we're going to learn, a lot of useful models and a way of thinking and a way of approaching questions to try to understand them. And in principle, we want models that work, and our models, we want them to be very clearly explained, and the clearest way of explaining models is with math. Math is very universal. So if we can make our models mathematical and very precise, we saw with, I know I took them off of the screen so you can't see them, but with Ziad's and Caitlin's models, it looked like they could work, but we would need some numerical testing. We would need to measure things, and that's good. If we do that and we make predictions that are numerical in nature, then we can measure things and compare those measurements with our predictions, and that's a really good way for us to falsify them if they're false, or show that they work if they work. All right, any questions about that metaphor? I know I'm not supposed to use metaphors in physics, but there, I did it. No questions? Okay, so this was the day with no math. This was our mathless day. Some people asked at the beginning, should you read math if you are rusty? The answer is, yeah, that would be a good idea to do tonight. If you haven't taken a math class in a couple of years, or even if you haven't taken math for a semester, and I know probably a lot of people in this class haven't had math math in years, because many people are maybe going for a new program and they found out they had to take physics to get into this program, and maybe you have been out of school and working for a while, and even if you're in, trust me, if you haven't had math in a little while, you need to review it, because it fades very quickly, but it comes back very quickly too. So I would, if I were to give you a recommendation, I would say review a little bit of algebra, in particular, solving equations with maybe 2 equations with 2 unknowns, and also quadratic formulas. That would be a good little review for you if you feel like you might be rusty. And tomorrow we will start learning some particular physics instead of an abstract discussion about what physics is. And we're going to very quickly need to be using our algebra skills. All right, does anyone have any questions for me before I stop recording? Okay, then I will stop.